This is Suresh, and today I will talk about Yolo V3 training. So, how to launch a training, how to set up conference, how to do inference. So, this is part of uh, uh, that is part of content. Yeah. So, I will take an example of a custom dataset. So, how to create a custom dataset, create a custom config file for the YOLO. So I am taking example of the cat and dog image datasets, and the dataset available this my Dropbox. So yeah, I will share this link to you also, so you will get that also. And for the training, we will use as a pre-trained model for, like, we pre-trained weights for next training, so that called darknet 53 that trained on the ImageNet. So darknet 53, the another name called YOLO v3. So this is the link for download that ImageNet, the pre-trained weight of that model. So we will use that. And so now I will explain about how to configure, how to create a config files, how to change in available configs for your custom training. So here, for example, we want to take a cat and dog dataset. So for the cat and dog dataset, we have to create a two file that called train.txt and call that test.txt and that object name. So I will explain that how to and where we have to place it. So here in my lab, so you'll see here that config file and that cat dog object.data. So we have to create this file in, we have to first clone the darknet repo. So we can clone the darknet repo from that official darknet website that called YOLO, that websites, and here that available example how to clone it and everything. So we have to clone it, and just we have to build the library using Mac. So we have to do that. After cloning, we have to enter in that particular location, and that particular location the config file, and yeah, Python script, all some example also is available there. So here in the particular configs, we have to create our configs like cat dog object.data. So this is custom created, and we have to put where our training and testing data script is there. So in training and testing data set script, so I will show where, like data uh, let's data dot and yeah. So this is the images, and like for creating the custom dataset, we have to create a text.txt file like that, pose.txt. So same name of image, we have to create a text file, and in particular text file we have to put their label like class name and bounding box. So it will look like I will show you that, and PA, and yeah. So it will look like this, like 0 is the class, 0 and 1 class, 0 is the dog and 1 is cat. So this class and this is the bounding box. So in text file we have to put, and all the information, the path information, we have to create two file like train and test.txt. So this is the train and test.txt I created, and we have to put a full path. So I will show here also that train and text.txt. So that test.txt, train.txt. So this is the file, and this is the path of images. So it will show the list of the path of images. So that's why we have to create two files, that train.txt and test.txt. So both information we have to put uh, in that config file. So cat dog.data, so where data is available, and here it will map this file map with your class like 0 class and 1 class. So in CFG file, like name.data, so there are two class, cat and dog. So we have to put here that cat and dog information in this file. So I put cat and dog. So cat is the 0 class, dog is the 1 class. So there are two classes is there. So I put here the two class. So this is the brief about uh, how to create data sets, and that how to, where we have to place the config file. Now I will go through about create where need to change in final in network. So generally if thinking about the ImageNet dataset, so there are 1000 classes. If you thinking about Coco dataset, there are 80 classes. So generally the default config file, so this is a cft.yolo v3.config is mapped with Coco dataset. So there are 80 classes, so we have to change 80 class to 2 class, and we have to choose number of the filter also. Yeah. So where we have to, and which level of network we have to change the classes here. So this is the brief about Yolo network. So Yolo network around 106 layer is there, and if we are thinking about particular staking, so staking that called 53 layer. So total layer is the 53, and total convolutional and all kind of networks that called 106. And here there are three level of uh, uh, prediction. So prediction number 1, there are layer number 79, it will predict a bounding box here. Layer number 9 and layer number 91, it will predict again a boundary box, and layer number 52. So there are three level of prediction. So use of three level, that is like in YOLO 2 network. So in YOLO 2, for example, if object size very less, your object size very small size, so it in YOLO 2 generally unable to detect. So YOLO 2 failed there, object size very less and accuracy. So somehow that YOLO v3 improve that, and it will use the fully convolutional network concepts. So in 79 layer and staking by the convolutional, and it will convolve by 1 into 1 convolution. And here after the downsampling, we are getting the feature map output size is equal to 13 into 13. So we are getting the output, and after convolving we are getting 13 to 250 size. So here, and again the level number 91, in 19 number then convolution, and here it will do upsampling. So upsampling, like here is 30 size, so it will do upsampling here, and we are getting 26 size. Similar one upsampling also in next level also, and they're getting result of 26 multiplied by 2 and 52 and 52. So finally in this 106 layer output is called output feature map is about 52 into 52, and depth is a 255. So there are three level of, we have to change the filter and number of class. So in config file I will go in the detail where we have to change. So here in config file, that is the YOLO v3 config file. In config file we have to change the number of batch size and subdivision. Subdivision help to decrease your GPU VRAM requirement. So if you if you decrease it, then it will decrease the GPU VRAM requirements. And so there are three level, 1, 2 and 3. So in 3 positions, I already told about that 3 we are getting the 3 results. So in 3 positions we have to change the number of class and number of filter. So the filter size depend on whatever number of classes there be, and number of predicted boundary box. So here number of predicted boundary box is 3, and boundary box 5, and 1 is the score class, that's why taking the 5 number, and number of classes is the 2. So total filter is, so number of classes, if we will do 2, then 2 plus 5 is 7, 7 multiplied by 3, so that called 21. So 21, so 21 filter. So where we need to change here, so we need to change in the config file. So I will open that config file. This is the config file, and here you will see that filter size is 21, which I changed it 21, I changed it number of class by 2. So previously it was 80, I changed it 2. And one another position that call middle, here also number of class I changed with 2, and filter size 21. And here the first upsampling, we are getting the first result, we are getting 103, sorry 603. So 603 here, number of class is equal to 2 and filter size 21. So there are three level of prediction, so three level we have to change all output classes and number of filters, so then we are predicting the results. So all things we changed here, and finally we are ready for the launch the training. So here how we can launch the training. So for the training is a simple command that called darknet detector train and cfg data and config file. We have to which config file we are using. So I change this config file and the pretend weight we are using darknet 53. So that pretended, and we have to run this command. So whenever I will run this command, so it will start the training. So here I run this command and it's start loading the networks. So total number of layer called 106. So total 106 is the layer, and like 91, and here upsampling will doing. So is 79, 91, and final output 106 they are doing, and training is started. So this training is still training running. So it's running on the CPU, so it's taking time. I can run it again for your use case. So I run it again. So it's load the weights, and it's load the pretend weights also. Yep. So right now loading weight and start training. So it's very slow because of the running on the GPU CPU. So you need GPU for accelerate your training. So this is all about how to launch a training with uh, Yolo v3. Now I will go through how we can make a prediction. So for the prediction, I will show example like here. I'll show example. I already did some prediction of cat and dog, so I will tag this, and you simply run this command for prediction. Also, it will load and it will load, and it will start the prediction. So I have already a trend model, so it will load the models and start the prediction. It's CPU, so it's taking time. I will tell also without command line how can you use Python script if you want to deploy the model on like any hardware that supports C, C++, or a Python. So I will show you about that. So it's taking time, just wait for a few seconds. So it will do the prediction because of running on the CPU. So this use case, yeah, like if you want to use Yolo v3, so I think low level hardware will not work here. We need to change the convert the model for the low level hardware also. So it still is taking time for make prediction. Okay, so meanwhile I will explain how we can make the prediction using Python script. So yeah, so in darknet in same directory you will get a Python script like Python and darknet.py. In darknet.py that is already example available, and yeah, so here this method to so this like load net, so it will load your your trend models. Like this is the Yolo v3 trend model, it's load, and it's take your made a config files like how many classes there, all things, so that it will take the meta information and it will detect. So this is two method for detecting and classify this for detecting and especially responsible for detect your bounding boxes, and it will return the bounding box, and it will return the class, and yeah, so all thing load the model, all things like this is the whole Python script. And simply like you want to do host a model, we can use whatever serving we want to use, like flash serving, yeah, like py serving, other serving, so that we can do. And yeah, if you target to low level hardware, so we can convert it to the low level hardware. So I will show here example how to make prediction. So like Python and let it clear and Python start prediction. So again it will load the model and it will start the prediction. Yeah, so right now we receive the result. The previous we launched the prediction here, and result look like it's able to detect now as a class of uh, there are three objects: dog, bicycle and truck. So right now we get the bounding boxes of their three classes. So this is we receive the results, and similar that Python files, in Python files also it's done, and right now start predicting, and we are right now somehow like few seconds more for predict the bounding boxes. So it will predict the bounding boxes and print here the bounding boxes. So yeah, so again it's a similar the previous prediction and get the bounding boxes. So this is the Python file for the inference. So I explain how to do inferencing and how to do training both for Yolo v3 models. Yeah, so I done all things. Any questions we have, then we can discuss about.